Let us continue with Kubernetes. This is a section where I'm going to explain what Kubernetes is. And I'm going to read. Kubernetes is a portable, extensible open source platform for managing containerized workloads and services that facilitate both declarative configuration and automation. Okay, you go to kubernetes.io and pretty much you're going to see the exact same definition verbatim. Okay, it was originally developed by Google. I originally named or influenced by something called Google's Borg, and it was released 2015. Okay, 9 years ago, almost 9 years ago. It's maintained currently by Cloud Native Computing Foundation, which is a partnership between Google and the Linux Foundation. And the last bullet um, explains that if your containers or the container system you use supports the container runtime interface, then you will be able to um, deploy your containers in Kubernetes. And here are some vendors that support the container runtime interface: Docker, Containerd, CRI, Mirantis, and so on. Okay. The screenshot to the right pretty much shows you, again, taken verbatim out of Kubernetes.io. Um, it shows us the list of vendors that currently support Kubernetes. Kubernetes has been getting a lot of traction, guys. So more and more companies are moving towards the I don't know, the infrastructure as code model type of a thing, and that's why you see so much support for Kubernetes. Okay, so it's here to stay. It's here to stay, and it's going to be with us for many decades. Cool. So that's what Kubernetes is. What does the architecture look like? The control plane is pretty much all the Kubernetes services that are there to support a Kubernetes cluster. Okay, so you have the different APIs. That pretty much is how you gain access to the different nodes. Think of a node as being a system, and its node can have multiple applications being deployed within it. Okay, be deployed within it. Um, the kubelet is pretty much how you communicate with the APIs and you manage the node. The kproxy is pretty much how you communicate or how applications communicate uh, intra or inside or outside the cluster, right? Let me put it this way, okay? Inside or outside the cluster, okay? The other thing that is important to know that an application that is deployed within the node by default only has network access to other applications who are deployed within the node. So it cannot see applications, it cannot communicate with applications that are deployed in other nodes or outside the cluster. Okay, so that's the default behavior. You have to create services. Okay. There is a legend. By the way, this is a screenshot yet again. It's taken verbatim out of kubernetes.io, and you will see the description of every single element of Kubernetes. Okay, I'm not going to read it for you. All right. Um, Workloads. What the heck is a workload? Again, there is a link. There is a link right here that if you click it, is going to take you under Kubernetes IO and it's going to describe all the different workloads. And I do that fairly consistently across the slides. So I do provide you with links so that you can go ahead and do more reading, especially for those of you who are not familiar with Kubernetes. Okay. Workloads. What the heck are workloads? Uh, I don't know. Pods, deployments, stateful sets, daemon set jobs, and cron jobs. These are all the different workloads. Okay. A pod, it's the smallest deployable unit. A pod, it's a set of containers. Could be a single container, could be multiple containers that implement that particular application, and they are deployed in a construct in a workload called pod. That's your smallest deployable unit. Okay, these are where your different applications are deployed at. Okay, everything else, deployment, stateful set, daemon set jobs, and cron jobs, these are for managing different pods, replicating the different pods so you have high availability and so on. Okay, clustering for parallel processing, etc. Okay. Now I did include services in the workload because from the perspective of a user, uh, a service is pretty much identical to the rest of the workloads. Well, identical is a bit of a strong word. I wouldn't say identical. I will say it closely resembles. There you go. That's a better description. Closely resembles all the other workloads. Okay. Um, Deployment. This is how you manage stateless applications. Okay. Stateful sets. This is how you manage stateful applications. Okay. Um, just to give you an understanding of the difference between stateful and stateless. Um, a stateless application it sends all the data to the application in order for the application to get the job done. Okay, if you compare to an HTTP request, my HTTP request contains all the data so that my server is able to satisfy that request. A stateful application, it sends part of the data. Some of the data are maintained at the server. Okay, so I'm sending, I don't know, part of the data. Everything else is managed by the server. It could be in memory, right? Could be in memory. It doesn't have to be in persistent storage. Okay, so that's the main difference. Daemon sets pretty much is you have a copy of the pod in every single node, right? These are usually for management, like logs, collections, storage, etc. Jobs, well, you start it, you complete it, you're done with it. And cron jobs, it's a job that runs on a schedule. That's what it is. Okay. Now a service, I started explaining services, but I never completed my explanation. A service is how you expose the application to the rest of the internet or the rest of the cluster. Okay, that's what it is. Um, a service, there are different types of services. There's cluster IP. Cluster IP means that the application can be is network accessible only from applications within the cluster. Right? It doesn't really matter whether it is in the same node or in different node. Right? If you have a cluster IP service, anybody, any application within the cluster can access it. Node port, it just opens a port on the cluster to access directly that application. Okay, poor man's networking. Poor man's networking. Load balancer. Load balancer, pretty much you have a load balancer fronting your cluster, and usually you need an ingress service in order to be able to communicate with the applications within the cluster. This is the most common setup, load balancer, that at least I've seen from my experience. Okay, and by no means am I a Kubernetes expert, right? My experience from everything I've seen, load balancer goes inside an ingress service, an ingress controller, and then the traffic is redirected to the rest of the applications within your cluster. Okay. External name, this is a DNS, right? This is a DNS server that gives you different host names, so you associate your different services with host names, and you are able to access your services that way. Okay, I've never seen this from my experience, right? All right, so that's the different workloads. Now here's a cluster architecture with ingress, right? I told you earlier on, the client sends request, it goes through a load balancer, and then you go through an ingress, uh, an ingress, um, an ingress controller. Okay, the ingress controller is um, is not manifesting. I'm looking for the right word. Employs. There you go. The ingress controller employs some kind of a proxy. It's usually Nginx. They could be traffic, right? And then the communication is sent across your application within your cluster. Okay, within your cluster. On our end, when we deploy our own cluster, we're going to be making use of an ingress traffic. Right? Why? Because K3D is bundled with traffic. even though Nginx is the most common, right? Is the most common. But the difference between the two are minute, right? Minute, very small, very, very small. Okay. All right, so that's what a cluster architecture with an ingress controller looks like. Now, what's the tooling available? Remember, managing a Kubernetes cluster, it's not easy. It's a big job. It is a big job. These are the different tools available to you. The ones that have their suffix with a star, these are the tools you and I will be using in our class. Okay. So K3D, this is our local Kubernetes cluster. Okay. Local Kubernetes cluster. And if I selected, it's going to take us to the website, and here it is. K3D. It's a lightweight wrapper around K3S. K3S is one of the most common Kubernetes distribution. There you go. Right? Rancher's minimal Kubernetes distribution. Okay, and it's deployed within Docker. So here's another prerequisite, right? We need to have Docker installed. Again, you don't use Docker directly, but it's needed. It's required. Okay. K3S, I believe, uses virtual machines. K3D uses Docker containers. Okay. Very simple, very straightforward. You can create a cluster within seconds, literally seconds. Okay. All right. Let's go back to the slides. Here we go. So K3D is what we're going to use to create our cluster. Uh, kubectl or kubecontroller, kubectl is how I usually call it, is what you use. You can use it to deploy application, inspect, manage your clusters, and so on. Generally speaking, this is a low-level utility, and we're going to use it in order to inspect our cluster, check logs, and so on. But generally speaking, uh, we're going to use Helm to deploy our application, right? Helm. Helm, think of it as being a package manager, right? Your package manager, where you go and you install applications. Okay, that's it. Uh, Minikube, Kind, these are other tools that gives you the ability to create local development type of clusters. In fact, all previous versions of this class used to use Minikube. It added additional complications primarily because Minikube doesn't give you access. It doesn't expose the cluster to the internet, right? K3D does, so it simplifies our class by quite a bit. Okay. Kind, very similar to K3D. Very similar to K3D. I've never used Kind. Uh, that's on my to-do list when I get some time to see whether Kind is better than K3D. But everybody I've seen thus far, local developers, they all make use of K3D. Right? So to me, that's a vote of confidence, and that's how actually I learned about K3D, and I was exposed to K3D, and I learned it, and I started using it in our class. Okay, kubeadmin, very important tool because this is the tool you should be using if you're building production grade clusters. Okay, now I believe maybe K3S has different ways of getting it done, right? That are easier than kubeadmin, right? But I'm not 100% certain whether I can still build a K3S cluster with kubeadmin. And again, building a production grade cluster, it's not easy, right? It's not easy. It's a hard task, very hard task. Okay. Okay. Cool. All right. So section with respect to explaining Kubernetes is done, right? That's your very brief introduction into Kubernetes for those of you who are not familiar. And again, there's tons of links, additional materials you can go ahead and start reading on your own and learning Kubernetes. Okay, learning Kubernetes. Section end. Talk to you next.